I'm Mary Botto. I've been with American Airlines for over 12 years.
Morning, I'm Hunter Easterday. I've been with American Airlines for a little bit under 2 years.
Hey, my name is Chang Kang. I'm a power plant engineer.
Hi guys, Adam. I work on the Boeing 737.
I'm Casey Stump. I do 737 fleet engineering too, but I do systems and structural.
Graduated from the University of Florida in 2021 with aerospace engineering.
I started off in line maintenance support, so whenever you're in the airplane and the pilot says, "I'm so sorry, we have a maintenance delay," my group was taking care of everything that was broken down.
What's fun about working on the airplane is that you never actually get to learn
and yeah, so it's like engineer entry level, then you're gonna have your engineer when you graduate, and then you can go to senior engineer, which is a lot of my colleagues here, and then principal will be like a manager, and then I have a senior manager.
Stress analysis or structural engineering, right? When it comes to aviation, the biggest thing is always safety, right? Is imparted on the structure while it's in the air, right? And then you also have to design it so that in an event of a crash, right, it can withstand those forces from a crash and not cause further injury to anybody.
I watched a movie when I was in high school called Toward the Sky. It's like about the space race. I don't know. It's an old movie.
You actually make a weave pattern. You basically make a clothing off of it, and then you layer that up, and then add a resin to harden it, and that's what's carbon fiber reinforced plastic. So what's so good about what's the difference with what the composite and the metal is a lot more lighter. You can kind of tap it. You guys can touch it and feel for it. So over here, you can kind of feel like the hollow a little bit. It's not really hollow, but it's a lot more lighter. The density, you can check kind of density by tapping on it. The titanium side is a little more.
push and pull with someone who's like super experienced with the hands-on part of it, but they don't know the engineering analysis. So then it's trying to overcome the barrier of
right? You, up till high school, you can think that you want to do something, but until you actually get into university and are able to apply what you're learning to different things, you may realize
It can be really hard to, like, if you don't make friends right away.
For my workout, it's like not a problem. Like, even if you think you just have an hour and you're like, that's not enough time to start something, it is. It's actually more time than you think it is. So finding like videos and that's what it's not
So like do your due diligence, go check if it's right. And sometimes people that are more senior than you can be wrong. But if you're signing off on like paperwork or you're putting like your engineering stamp on it, then you're approving it too. So really
when it comes to working for an airline like American, if you enjoy what you do at that company, amazing, right? But if you can't enjoy what you do outside of the company, it's not that great, right? But the fact that they allow you to travel, it gives you that avenue. Okay, I have my
knowledge there. What did you want to do? Software engineering? It's going to be too long, so the planes next would have to be short because of the wingspan, so you can't have them hitting. So coming up with the best graph of the best planes and utilization.
Okay, so you guys make this 3D Autodesk.
What they do is they have to go up and they have to do a quick go around and then come back down. So that's what they do.
After that happens, they just like go back down.
Yeah, they have to just maneuver because you have to think there's also 7 other planes waiting to land on that runway at the same time. So you can't just like abort and then now where do those planes going to go up there? So you have to figure out the safest route for it to go up and come back down. Right, yeah, crosswinds, people, other traffic that's coming in because your runways don't just go left to right, they can also go this way or they can go this way depending on what city you're in.
Like 2 hours, 3 hours. But they had to discontinue doing it because it wasn't very safe and also it was too expensive because it was basically a jet engine, like it was basically a jet plane, like a military jet plane that could take hundreds of people. So you can kind of imagine how much fuel that is burning going how fast they are going. But now that we are improved on the structure side, like a material example, example, we found out that we can make things out of composite, there's a chance that they're going to make a new subsonic airplane for passengers. It's probably made out of composite, so it's a lot more lightweight, and they have made a better engine, so it makes more fuel efficiency. So all the negative things that they discontinued the program for Concorde, we have made a lot of improvement on small little things, and maybe they can actually all put together into one airplane again and try it out again and see if we can make a better, actually safer and faster airplane.
I think definitely things like that, like composites are like a big feature in airlines. Like Boeing 787 is all like largely composite aircraft. So is the Airbus A350. So that's something that like kind of crossed that barrier, and they're starting to make aircraft out of composites, carbon fiber, computer layups, and things like that. The way they do the 787 is like very cool. They actually like lay up like whole circular sections and like bake them in this giant autoclave. It's like a giant oven, basically.
Oh, yeah,
huge. And then
See, there's like GM, Arlington, automotive, there's process engineering, there's like you can work in machine shops as an engineer if you like AutoCAD and drawing, and you don't necessarily, let's say you don't want to do like defense or anything like that, you could go work in machine shops and you could like draw their parts. Like the company would be like, okay, I need this part, can you draw me up like a schematic? And then an engineer at the shop, they can then do the drawings if you like. So I learned SolidWorks, but there's like AutoCAD, Inventor, a whole bunch of them that different people use. So all kinds of stuff like that.
One piece of advice you would tell your high school self?
It's just there's people interviewing you and you're like, oh, I think this person would be really good in this group. So you might get placed, like I was placed in power plant engineering with like the engines of the aircraft. But you can get placed in fleet, which is like the group I'm in now. There's like shop support engineering. So up in Tulsa we have our main base. And so you have machine shops there, you have like paint shops, you have overhaul lines where they'll completely strip the plane down and then do any repairs that are needed.
One of the most complicated supply chain like fields is an airline, right? Because you have moving planes, but when those planes need parts, you have to figure out how to get a part to a moving plane.
So this is a fan blade on the 737 MAX engine from LEAP-1B engine. These are pretty new technology, basically.
Thing called composite. So these are basically a graphite, carbon fiber, reinforced plastic that's laid together. So it's a lot more lighter than traditional metal. So they actually fuse the titanium and the carbon fiber reinforced plastic together to make a fan blade, but yet a little more lighter, so it's a lot more fuel efficient. So that's what it is. There's a titanium wrapped around in these carbon fiber layers, and there's actually delamination, which means that whenever carbon fibers lay on each other, it's called plies, they start deteriorating, start splitting. So that's the reason why we had to remove it, because it's no longer serviceable.
How heavy is it?
How much does one fan blade cost?
We have a robot.
Alright, that's it.
And also, I know there are some aerospace guys over here. Those fans, they're curved in like you know, specific way, so that actually is aerodynamic and it draws air more efficiently, right? And just just a flat, you know, fan basically that you guys.
Those are the
use.
carbon fiber layers.
Oh.
Yeah.
There's another carbon fiber float on it, and float resin, fiber, resin, fiber, resin, fiber.
Yeah, so that's what rips through the air.
That black part is.
So main engine really can't start on its own. You need some kind of air compression to actually start the engine. But we figured that out that, hey, you know what? That 4 engine, it uses a lot of fuel. We can maybe make 2 engine, but make it more efficient and fly more further. So that's kind of the trend nowadays, to make airplane more efficient, more lighter, and more faster, and more fuel efficient.
You have those 2 big the engines on the wing. So that type of engine is called a high bypass turbofan. Basically what that means, it sucks a lot of air, right? And it pushes itself by pushing a lot of air, but then it also combusts a little bit of air. A propeller engine, you can have a turboprop, right? Which uses a similar principle in the commercial airline engine to spin a propeller. And that propeller creates thrust, right? It pulls the airplane through the air. Classes is mechanical, but they might take 1 or 2 extra classes that are more aerospace focused. Since I do structures work, in aerospace you do a lot of aerospace, you have a class called aerospace structures, which literally teaches you how an airplane is put together, what are the different components, the metal components that come together, and then how to determine how all of those components are loaded, right? How does all of the weight and the force distribution, how does that get balanced out? So since I do primarily structures projects, I use my degree every day.
So within those systems you have lots of valves, fluid flow, and you sometimes have to help troubleshoot on where issues are coming about. So let's say you're having issues with your fuel transferring between the tanks, it's constantly happening, and they're like, all the valves check out, you don't really know what's going on, and you have to then go through the systematic diagrams and see like, okay, it could be this problem, maybe it's this problem, and you can pull the valves and like look at them internally, because they have lots of internal components that you don't always see. And then also things will act differently on the ground versus up in the air. So you have to always consider a whole bunch of different aspects. And in school we learn all about the different valves, you learn about fluid flow, heat transfer, so you do use all of those things at our jobs too.
Support everybody, so sometimes I work power plants, sometimes I work systems, structures, avionics.
Plane. It's just a all series of relays and signals that when you press a button, make things start.
And that's pretty much taking all the data points that you get and making it readable for an engineer or for someone else, an analyst, to figure out exactly what's going wrong with an aircraft. In 200 cycles, we're going to possibly have a hot engine event. So we're going to stop it sooner so we can make sure that all the seals, all the valves, all the wiring is actually still good and intact.